Assalamu alaikum wa rahmatullahi wa barakatuh. Students, today we are starting 13.6 exercise of surface area and volumes, class 9th. Let's have question number 1. Question number 1 says the circumference of the base of a cylindrical vessel is 132 centimeter. So we have a cylindrical vessel. Let's make a cylindrical vessel. This is a cylindrical vessel and it says the circumference of the base of the cylindrical vessel is 132 centimeter. This is the circumference of the base, so this is 132 centimeter. Circumference of the base, that means circumference of, as far as cylinder is concerned, you have upper base and the lower base. Upper base is circular, both the bases are circular. So the circumference of this lower circle is the circumference of the base. And its height is 25 centimeter. Height is 25 centimeter. How many liters of water can it hold? So you need to tell that how many liters of water it can hold. That means you need to find the capacity, and that's the volume. So let us find the volume of this cylindrical vessel. Here, circumference of base is 132 centimeter, which implies that you know circumference is equal to twice pi r. That is 132. Then you can go 2 ones. 2, 6, 12 and 2, 6, 12. You got it? Therefore, R is equal to 66 by pi centimeter. This is the radius. 66 by pi centimeter is your radius. Height is the height of cylinder. It is equal to 25 centimeter. Height of cylinder is 25 centimeter. Since you know volume of cylinder is equal to pi r square h. That is equal to pi. R is 66 by pi. Then we have a square, so pi r square, h is 25. Then you go pi times 66 by pi times 66 by pi times 25. Now pi and pi gets cancelled. Then for this you can write 66 times 66 times 25 times 7 by 22, because it's 22 by 7 in division, so on multiplication it will become 7 by 22. Now let me solve this. So you have 66 times 66 times 25 times 7 divided by 22, so that will give you 34650. And what is this? 34650 is cubic centimeters. Cubic centimeter. Now you know the conversion. 1 liter is equal to 1000 cubic centimeters. This is the conversion which you will use here. 1 liter is equal to 1000 cubic centimeter. That means 1 cubic centimeter is equal to 1 by 1000 liters, and this much cubic centimeter is equal to this divided by 1000. So you go 34650 divided by 1000. Now you are in liters. So that will give you 3.46 34.65 34.65 liters. And that is the capacity of this vessel. So this much liters of water it can hold. So you can write therefore capacity of vessel is equal to 34.65 liters. Hence, the required amount of water it can hold is 34.65 liters. And that's your answer. Make a note. Then we have question number 2. It says the inner diameter of a cylindrical wooden pipe is 24 centimeter and its outer diameter is 28 centimeter. The length of the pipe is 35 centimeter. Find the mass of the pipe if 1 cubic centimeter of wood has a mass of 0.6 gram. So, inner diameter of a cylindrical wooden pipe. We have a wooden pipe like this. This is a wooden pipe. Just like this. Inner diameter of the cylindrical wooden pipe is 24 centimeter. Inner diameter, that means this is 24 centimeter. Inner diameter of the wooden pipe. And its outer diameter is 28 centimeter. Outer diameter is 28 centimeter. Just like this. The length of the pipe is 35 centimeter. Length is 35 centimeter. Find the mass of the pipe if 1 cubic centimeter of wood has a mass of 0.6 gram. Let's see. That means we need to deal with the volume first. Let us find the volume of this wooden pipe. Here, inner diameter and outer diameter. Inner diameter. Inner diameter, let's name it D1. Inner diameter D1, that is equal to 24 centimeter. Outer diameter D2, that is 28 centimeter, which implies that inner radius radius, let us say R1, that is 24 divided by 2, and that will give you 12 centimeter. Then outer radius, R2, that is equal to 28 divided by 2, and that is 14 centimeter. 14 centimeter. So we have both inner radius as well as outer radius. Then we have length of pipe, that is equal to height of cylinder, because in this case this pipe is cylindrical, so length of the pipe is height of the pipe. So length of pipe is equal to height of pipe, and that is how much? That is, length of pipe is equal to height of cylinder, 35 centimeter. 35 centimeter. Then let us find the volume. Since volume of wood, volume of pipe, or you can say volume of pipe, because it's a wooden pipe, so volume of pipe, it is equal to volume of cylinder. Volume of pipe is volume of cylinder. Volume of cylinder. And that is equal to pi r square h. Since we have outer and inner radii, that means at that time we take capital R, and capital R is equal to outer minus inner. You know that. So pi r square. This r is the combined outer and inner radius. Now you can substitute. Pi is 22 by 7. You can take that. So it's like this: pi. Now this is r outer square minus inner square, then times h. Then you have 22 by 7 times, now r2 is 14 square, minus r1 is 12, then you have square, then times h is 35. H is 35. Then you can solve this. Six minus 144, so I got 52 times 35 times 22 divided by 7. So you have 5720. 5720 what? 5720 cubic centimeters. This is the volume of this pipe. Now I would say is mass of wood per cubic centimeter. That is how much? Mass of wood per cubic centimeter is 0.6 gram. 0.6 gram. Therefore, mass of wood for 5720 cubic centimeters is 5720 times 0.6 times 0.6, that will give you 3432 grams, or you can go in kgs. 3432 divided by 1000. Now on dividing 1000 to grams, you are in kgs now, and that will give you 3.432 kg, and that's your answer. So you can hence the required, hence the required mass of wood is 3.432 kilograms. That's your answer. Make a note. If you are not getting a chance, then you can pause the video for a while and you can make note easily. So let's have question number next. A soft drink is available in 2 packs, a tin can with a rectangular base of length 5 cm and width 4 cm, having a height of 15 cm, and a plastic cylinder with circular base of diameter 7 cm and height 10 cm. Which container has the greater capacity and by how much? This is a simple question. You can take both the containers, a cuboidal one, rectangular with rectangular base, that's a cuboid, and a cylindrical one, that's a cylinder. All the dimensions are given. You can find the volume of cuboid, then you can find the volume of cylinder. Then you see to it that which container has the greater volume, that will have the greater capacity. So by how much means you can subtract the smaller one from the larger one, you'll get it easily. So it's a simple question. Let's have the next question. Question number 3 is for you guys. If the lateral surface area of a cylinder is 94.2 square centimeter and its height is 5 centimeter, then find radius of its base, its volume. Lateral surface area of cylinder is given. You have a cylinder. It's simple. Lateral surface area is given, that is 94.2 square centimeter, and its height is 5 centimeter. Height is given 5 centimeter. Find the radius of the base. You need to find the radius of the base. Again, this is a simple question. This is the lateral surface area. Now you can apply the formula for lateral surface area, that's equal to pi r square h, and height is given. You can equate that result to the lateral surface area, you will get the radius C. Pi r square h is equal to 94.2. Now h is given 5, so pi r square times 5 is equal to 94.2. So only one variable is left, that's r. So you can solve this, you will get the radius of the base. Then you need to find its volume. Then you have radius. Sorry. It says lateral surface area. Lateral surface area is twice pi r h is equal to 94.2, because this is lateral surface area. Again, that will give you twice pi r. H is 5 is equal to 94.2. So you'll get r easily because only one variable is here in equation. So you'll get the r. Now after r, you'll apply pi r square h. Then put this r here, and height is given. You'll get the volume of this cylinder. Then, if it costs rupees 2200 to paint the inner curved surface area of a cylindrical vessel 10 meter deep, if the cost of painting it at the rate of rupees 20 per square meter, find the inner curved surface area of the vessel, radius of the base, capacity of the vessel. Again, the simple question. It says that the cost of the paint, let me show this, question number 5. Inner curved surface area of the cylindrical vessel. We have a cylindrical vessel. This is a cylindrical vessel. Inner curved surface area. To paint the inner curved surface area, let me go like this. So it's like this. To paint this inner curved surface area, it cost us rupees 2200. Or rupees 2200. So let me go. Say 10 meter deep. 10 meter deep means height is 10 meter. If the cost of the painting is at the rate of rupees 20 per square meter, and cost is at the rate of rupees 20 per square meter, rupees 20 per square meter, then find the inner curved surface area of the vessel. Let us see how. Here you don't know the radius, you know the height. Height of cylinder is 10 meter. Height of cylinder is 10 meter. Now, let's find the inner curved surface area. Let the radius of base be r meters. Let the radius be r. Since lateral surface area of cylinder lateral surface area of cylinder is equal to twice by r h. Now you don't know the lateral surface area, which implies that inner curved surface area, inner curved surface area, that is CSAI, inner curved surface area, it's again equal to twice by RH, and that is equal to twice by radius is how much we don't know, it's r, then we know height is 10, then times 10, that will give you 20 by r square centimeter. 20 by r square centimeter. This is what? This is the inner curved surface area of this vessel. Now cost of painting. Now cost of painting the CSAI cost of painting the CSAI, inner curved surface area. Now cost of painting the inner curved surface area per square meter is how much? Is rupees 20. Is rupees 20. Therefore cost for this much 20 by r square meters is equal to 20 by r times 20, and that will give you rupees 400 pi r. 400 pi r. This is what? This is the cost for, this is the total cost for painting the inner curved surface area. The question says that is 2200. According to condition, that cost 400 pi r, it is nothing but 2200. 2200. Let us solve for r. Solve for r, what do you get? Cancel 1 0 with 1 0, 1 0 with 1 0, 4, 2 2s 4, 2 1s 2, 2 1s 2. So you'll get r here, which implies that 2 pi r is equal to 11. So that means r is equal to 11 by twice pi. 11 by twice pi. That is your radius. 11 by twice pi centimeter. Sorry, meter. So that's your radius. 11 by 2 pi. Therefore, now let us find the inner curved surface area. Therefore, CSAI is equal to, of vessel rather, CSAI, inner curved surface area of vessel, that is equal to, we have that 20 pi r, 20 pi r. That is equal to 20 pi, then 11 by 2 pi, times 11 by 2 pi. Now pi and pi gets cancelled. 2 1s, 2 10s. That will give you 110 square meter. And that's the answer of your first part. Yes, it's 110 square meter. Make a note. That was, by the way, that was the first part of your question. The second part is radius of base. For radius of base, you can use this expression, 11 by 2 pi, then use put the value of pi here, 22 by 7. You will get the radius. Then third one is capacity of the vessel, that is the volume of the vessel, pi r square h. Pi 22 by 7, then r you have this square h is already given, so you'll get the volume as well. Make a note. Then the next question, the capacity of a closed cylindrical vessel of height 1 meter is 15.4 liters. That means volume is given. How many square meters of metal sheet would be needed to make it? Question number 6. The capacity of the closed cylindrical vessel. Closed cylindrical vessel means you need to consider the total surface area. This is a closed cylindrical vessel. Its capacity is of height 1 meter. So height is 1 meter. its capacity is 15.4 liters. 15.4 liters is the capacity. How many square meters of metal sheet would be needed to make it? So you need to find the amount of metal sheet required to make it. That means we have to deal with the total surface area. Let us find the total surface area of this cylinder. Here, nothing else is given. Yes. Here, height of cylinder is equal to 1 meter. Then you have volume of cylinder, it's given. It is 15.4 liters. 15.4 liters. Let us convert this to cubic meters. You know the conversion. 1 cubic meter is equal to 1000 liters. So this conversion we'll use here. 1 liter is equal to 1000 cubic centimeter. 1 cubic meter is equal to 1000 liters. So that means 1 liter is equal to 1 by 1000 cubic meters. When 1 cubic meter is 1000 liters, so 1 liter is equal to 1 by 1000 cubic meters. So this much liters is divided by 1000. Now you are in cubic meters. Got it? So 15.4 divided by 1000, that will give you 0.0154 cubic meters. Now that is your volume, which implies that. But you can find volume by applying the formula pi r square h. Yes? And that is, you can equate with 0.0154. After that, you know the height. Height is 1, so you have pi r square times 1 is equal to 0.0154. In that case, you'll get r square is equal to 0.0154 divided by pi. And that's your r square. That's your r square. So that is 0.0154 divided by, is it 3.14? No, 22 by 7. And that is 0.0154 times 7 divided by 22 times 7 divided by 22, so you'll get, which implies that r square is equal to 0.0049. Then you'll get r as 0.0049 under the radical, square root of 0.0049. That will give you, therefore r is equal to 0.07 meter. This is your radius. So you got your radius. Then after that, you need to find the total surface area. Since TSA of vessel, that is equal to TSA of cylinder, and that is equal to twice pi r times h plus r, and that is equal to twice 2 times 22 by 7 times radius is 0.07, then bracket start, height is 1, then plus 0.07. That is your total surface area. Let me solve this. Times 0.07 times 0.4708 now square meters. Square meters. So we can write hence the required, how many square meters of metal sheet would be needed? Hence the required amount of metal sheet, hence the required amount of metal sheet is 0.4708 square meters. And that's your answer. Make a note. The next question, a lead pencil consists of a cylinder of wood with a solid cylinder of graphite filled in the interior. The diameter of the pencil is 7 mm and the diameter of the graphite is 1 mm. The length of the pencil is 14 cm. Find the volume of the wood and that of the graphite. That's a simple question. It's like this. Inside we have the graphite, it's like this, the graphite inside the wood, it's a pencil. Now the diameter of the pencil is 7 mm. The diameter of the pencil is 7 mm. And diameter of the graphite is 1 mm. So this diameter is 1 mm. Diameter of the graphite. The length of the pencil is 14 cm. Length is 14 cm. Find the volume of the wood and that of the graphite. Now you can go easily. Volume of the wood pi r square h. But when you find the volume of the wood, you need to consider the pi. When you do pi r square h, you need to consider outer minus inner. So that means pi r2 square minus r1 square. Then 4 times h. R2 is the outer radius, so you'll get it from 7 by 2. Now R1 is the inner radius, 1 by 2. So you'll get the volume of the wood. And volume of the graphite is easy to find. Pi r square h with height this. Both times your height is 14 centimeter. In both the cases your height is 14 centimeter. Now in case of graphite, your height is 14 centimeter and your radius is 1 by 2. That's 0.5. So you'll get it easily. Then question number 8. A patient in a hospital is given soup daily in a cylindrical bowl of diameter 7 centimeter. This is a cylindrical bowl in which a patient is given soup daily. Just like this. Diameter is 7 centimeter. Diameter 7 centimeter. If the bowl is filled with soup to a height of 4 centimeter. Now soup is filled, for example here, to the height of let us say soup is filled to this height 4 centimeter. How much soup the hospital has to prepare daily to serve 250 patients? Now it's easy. So find the volume of cylinder up to this mark. So I'll get pi r square h. R is 7 by 2. So pi r square h is this. So on solving this, now solve this, you'll get some amount. Then what you can do, for example, into 22 times 7 times 7 times 4 divided by, so you have 154. Then you have how many patients? So you'll get 154 for this, 154. Then you have 250 patients, so times 250. So you'll get 38500 square centimeter. You need to tell how much soup. So 38500 square centimeter. Square centimeter. Or you can go in liters. This is square centimeter. Or you can go in liters. You know the conversion. Sorry, this is cubic centimeter. Go in liters. Divided with 1000. So you have 38.5 liters, and that's your answer. But it's a simple one. Now let's have exercise 13.7. Question number 1. Find the volume of the right circular cone. Now radius is given, height is given. Radius and height is given. You can find the volume of cone, that is 1 by 3 pi r square h. R is given, h is given. Put the values and you'll get the result. When the capacity in liters of a conical vessel with radius 7 cm, slant height 25 cm. Radius is given, slant height is given. You need to find the volume. So now for volume you need h. H you'll get from under root h. See how? I'll tell you one thing. Let me show you question number 2, part number 1. It's a conical vessel. This is a conical vessel with some slant height given. This is 25 centimeter. The radius is 7 centimeter. Radius is 7 centimeter. Here, R is 7 centimeter. Slant height is 25 centimeter. You can find h. How? You know the conversion. L is equal to square root of h square plus r square. In that case, L square is equal to h square plus r square. In that case, L square minus r square is equal to h square. So that means h is equal to square root of L square minus r square. Got it? H is L square minus r square. Under the radical, so L is 25 square minus r is 7 square. Now that is 625 minus 49. 576, that is 24. So this would give you 24 centimeters. Now you have height, you have radius, you can apply the formula for volume 1 by 3 pi r square h. R is given, h is given, so you'll get the volume easily. Question number 3, the height of the cone is 15 centimeter. If its volume is 1570 square cubic centimeter, find the radius of the base. Again, height is given. Let me show you the third one. Let the radius of cone be r centimeter. Got it? You need to find the radius, let it be r. If the volume is, height is 15 centimeter. Height of cone is 15 centimeter. And also you are given with volume 1570 cubic centimeter. Volume of cone is equal to 1570 cubic centimeter. 1570 cubic centimeter, which implies that volume of cone is pi r square 1 by 3 pi r square h, and that is equal to 1570, which implies that take pi 3.14 1 by 3 times 3.14, because question says so. 1 by 3 times 3.14 times r is, you don't know, so r square times h is 15 is equal to 1570. Then you find r square is equal to 1570 times 3 divided by 3.14 times 50. Let me solve this. Times 15, 47.1. 1570 times 3 divided by, so you get 100, which implies that r is equal to square root of 100, therefore r is equal to 10 centimeter, and that's your answer. Make a note. After this, you have question number 4. If the volume of a right circular cone of height 9 centimeter is 48 pi cubic centimeter, find the diameter of its base. Now volume is given, height is given, so diameter, again you can equate r, you can find first r, then you can multiply 2, you'll get the diameter. Same question. A conical bit of top diameter 3.5 meter is 12 meter deep. What is the capacity in kilometers? Diameter is given, height is given, so from diameter you get the radius, and height is already given, so you'll find the volume. Then volume will be in cubic meters. Now you need to go to the kiloliters. Kiloliters is, remember the conversion for this. Let me show you this question. Question number 5. You have a conical bit. Let's just say this is a conical bit with some height given. Conical bit of top diameter 3.5 meter, diameter is 3.5 meter. the height is, it's 12 meter deep, so 12 meter is the height of this cone. Find the capacity. See, here diameter of cone is equal to 3.5 meter, which implies that radius of cone is equal to 3.5 divided by 2, and that will give you 1.75 meter. Height of cone is also given, that is 12 meter. Therefore, volume of cone is 1 by 3 pi r square h. That will give you 1 by 3 times 22 by 7 times radius is 1.75, then do the square, then times height is 12 times 1.75 times 12 times 22. That will give you 38.5 cubic meters. Now there's a catch. See, 1 cubic meter is 1000 liter. 1 liter is 1000 kiloliter. 1 liter is 1000 kiloliter. Sorry. 1 kiloliter, because kilo is 1000, like 1 kilometer is equal to 1000 meters. Similarly, we have 1 kiloliter is equal to 1000 liters. Now, if you pay attention, this is exactly the same thing. So, what you got from here is that 1 cubic meter is nothing but 1 kiloliter. So that's the same thing. If you are going in kiloliters, that's the same thing. 38.5 cubic meters, or you can say 38.5 kiloliters, and that's your answer. Got it? Make a note. Now after this, we have the next question. The volume of a right circular cone is 9856 cubic centimeter. If the diameter of the base is 28 centimeter, find height of the cone. Diameter is given, volume is given. That means from diameter you get the radius, and the volume is given, so equate the result. For the volume, so 1 by 3 pi r square, this is equal to 9856 cubic centimeter, you will get the height, simply. Then slant height, h square plus r square under the radical. Then curved surface area of the cone, pi r l. You have l, you have radius, you have pi, so you will get the curved surface area easily. Question number 7. A right triangle ABC with sides 5, 12 and 13 centimeter is revolved about the side 12 centimeter. Find the volume of the solid so obtained. Let me show you question number 7. You have a right triangle ABC. ABC. This is a right triangle ABC with side 5 centimeter, 12 centimeter and 13 centimeter. 5 centimeter, 12 centimeter and 13 centimeter is revolved about this side 12 centimeter. Now this triangle is revolved about along this side, revolve like this. Got it? Find the volume of the solid obtained. When a triangle is revolved around a side, revolved around a side. Around means take this side like this. Now, if I say, for example, like this, revolve this marker around this marker. So that means I'm doing this thing. Got it? Yeah. Similarly, it says revolve the triangle around this 12 centimeter. Yeah. So you'll get a cone. Now revolve the triangle around the side, you'll get a cone. You'll get a cone. So let us say you got like this. You got like this. So you got this cone. You got cone like this. Now you need to find the volume of this solid, that means volume of this cone. And for this cone you have height 1 by 3 pi r square h. So you have height and you have radius. Got it? So here radius of cone is equal to 5 centimeter. Height of cone is equal to 12 centimeter. Therefore, volume of cone is 1 by 3 pi r square h. 1 by 3 times 22 by 7 times 5 squared times 12. That will give you 22 times 25 times 12 divided by 21. And that will give you 314.28. Let me just do one thing. Keep pi as such. Do not give the value of pi because the answer is in terms of pi. So 1 by 3 times pi times r is 5 square times height is 12. Now solve the rest of this. You'll get 5 is 25, 25 times 12, that will give 300 divided by 3 and that's 100. So you have 100 pi cubic centimeter. And that's your answer. Question number 8. If the triangle ABC in question number 7 above is revolved about the side 5 centimeter. Now it's other way around. Make this as base. Now it's like this. Now this is 12 centimeter and this is 5 centimeter and hypotenuse is as such. Now revolve this triangle around this 5 centimeter. So you again will get some cone like this. Now then find the volume of the cone so obtained. Now you need to find the volume of this cone. Got it? Volume of this cone is height this, radius this. After that it says find also the ratio of volumes of the two solids obtained in question number 7 and 10. Then you need to do 100 pi divided by the answer of this. Here what you will get? You get 1 by 3 pi r square h. Because r is this, so you will get 144 times 5 divided by 3, so you have 240 pi. 240 pi. Now find the ratio. Pi gets cancelled, 0 gets cancelled. 2 5s 10, 2 12s 24. So 5 is to 12 is the required ratio. Got it? And that's your answer. Then question number 9, a heap of wheat is in the form of a cone whose diameter is 10.5 meter and height 3 meter. Find its volume. The heap is to be covered by canvas to protect it from the rain. Find the area of the canvas required. Now it's simple. The heap of wheat is in the form of a cone. This is a heap of wheat. Just like this. Diameter is 10.5 meter. Height is 3 meter. Got it? Find its volume. Now you can easily find from the diameter you get the radius 1 by 3 pi r square, which is the volume. R is given, H is given. Then the heap is to be covered with a canvas to protect it from the rain. Find the area of the canvas required. Now you need to find the area of this. What is called curved surface area of cone. That is equal to pi r L. Now first of all, get L from this formula, h square plus r square. You have height, you have radius, so you'll get h. Then do pi r L, you'll get the curved surface area, and that is the amount of material required for the canvas to make. Got it? Hope you understand this. And with this, we are done with this exercise as well. Let's have the last exercise, that's 13.8. 13.8. Find the volume of the sphere whose radius is 7 centimeter. Volume of the sphere. Now in this exercise you have to deal with sphere and hemispheres and the volume of these figures. Volume of sphere is 4 by 3 pi r cube. Radius is given, so you will get it easily. Find the amount of water displaced by a solid spherical ball. Solid spherical ball of diameter 28 centimeter. Now diameter is given. Amount of water displaced is equal to the volume of that object which is immersed into the water. So Archimedes principle. So that means you need to find the volume of the ball. Diameter is given. From diameter you get the radius. Then you apply 4 by 3 pi r cube, you'll get the volume. That is the amount of water displaced by that very ball. The diameter of a metallic ball is 4.2 centimeter. What is the mass of the ball? If the density of the metal is 8.9 gram per cubic centimeter. It's a very good question. Let me show you the third one. The diameter of the metallic ball is 4.2 centimeter. We have a metallic ball. Its diameter is given. Metallic ball. Its diameter is 4.2 centimeter. This is the diameter. And it's 4.2 centimeter. What is the mass of the ball? if the density of the ball is 8.9 gram per cubic centimeter. 8.9 gram per cubic centimeter. This is the density of the ball. Let us start with the diameter here. Diameter of ball is the diameter of sphere. And that is given, that's how much? 4.2 centimeter. Which implies that radius of ball is equal to radius of sphere. And that is equal to 4.2 divided by 2. That will give you 2.1 centimeter. Got it? Then we have density. Density is denoted as the symbol rho. Density of ball is equal to how much? 8.9 gram per cubic centimeter. Got it? Now you know density is equal to mass per unit volume. Density is the mass per unit volume, which implies that, so this is mass of ball divided by volume of ball. Because density is mass per unit volume, it is equal to 8.9, which implies that. Now mass of ball is equal to 8.9 times volume of ball. Got it? Now that is 8.9 volume of ball is volume of sphere. And that is nothing but 8.9 volume of sphere is times 4 by 3 pi r cube. And that is 8.9 times 4 by 3 times 22 by 7 times, now r is 2.1, so you have 2.1 cube. Now let us solve this. So you have 8.9 times 4 times 22 times 2.1 times 2.1 times 2.1 divided by 21, that will give you 345.3912 what? Gram. Or you can say which is of the order 345.39 grams. Got it? And that's your answer. Therefore, mass of ball. Because we were required to find the mass of ball. Make a note. Now, question number 4. The diameter of the moon is approximately 1/4 of the diameter of the earth. What fraction of the volume of the earth is the volume of the moon? Question number 4. Diameter of the moon is approximately 1/4 of the diameter of the earth. Let the diameter of the earth, diameter of earth be dE. Let the diameter of earth be, or you can say simply d. Let the diameter of earth be d. Therefore, diameter of moon is equal to d by 4, because it says it's 1/4 of the diameter of the earth, so it's d by 4. Now let us find the volume of, which implies that radius of Earth is equal to d by 2. Radius of Moon, let's say r dash, it's equal to d by 4 times 1 by 2, that is d by 8. Got it? Now, then volume of Earth. Volume of Earth is 4 by 3 pi r cube, and that is equal to 4 by 3. Keep pi as such. The radius of Earth is d by 2, then d by 2 cube. That is how much? That is 4 pi d cube. By 2 to 4 to 8, 8 3s 24. Now that is equal to 4 1s 4 6. That is equal to pi d cube by 6. And volume of Moon is equal to 4 by 3 pi r dash cube. It is equal to 4 by 3. Keep pi as such. Now r dash is d by 8. D by 8 cube. That will give you 4 pi d cube divided by 8 cube is 512. 8 times 8 times 8 is 512. Yes. Now 512 times 3. That will give you 1536. 1536. Then you can go 4 1s 4. 4 4s 16. 4 4 16, sorry, 4 3s 12. 4 3s 12, 15. Then you have 33, that is 4 is 32, 4 4 16, am I right? Divided by 4, 3 8 4, yes. So you'll get pi d cube by 384. Now it says, what fraction of the volume of the Earth is the volume of the Moon? Now get the ratio first, which implies that volume of Earth divided by volume of Moon, volume of Earth divided by volume of Moon, that will give you pi d cube by 6 divided by pi d cube by 384, and that will give you pi d cube divided by 6 times 384 divided by pi d cube. Now pi d cube gets cancelled. 384 divided by 6, that will give you 64. So question says, what fraction of volume of Earth is the volume of Moon? That is 64, 1 by 64. 1 by 64. Now you can write like this, which implies that volume of Earth is equal to 64 times volume of Moon. 64 times volume of Moon. Then it says, what fraction of volume of Earth is the volume of Moon? What is volume of Moon? Therefore, volume of Moon is equal to 1 by 64 volume of Earth. Hence the required fraction is, hence the required fraction is 1 by 64. And that's your answer. Make a note. Then you have question number 5. How many liters of milk can a hemispherical bowl of diameter 10.5 meter, 10.5 centimeter hold? Again, it's a simple. You have a hemispherical bowl, radius is diameter is given. From the diameter you'll get the radius, and you need to find the volume in liters. Now volume is equal to 2 by 3 pi r cube, because it's a hemisphere. Hemisphere is 2 by 3 pi r cube volume. Now when you get the volume, you'll get it in cubic centimeter. Then convert that into liters. You know the conversion for the liter to the cubic centimeter to liters. A hemispherical tank is made up of an iron sheet 1 centimeter thick. If the inner radius is 1 meter, then find the volume of the iron used to make the tank. Again, question number 6 is the simple question. You have a hemispherical tank. Hemispherical tank is made up of an iron sheet 1 centimeter thick. It's like this. This is the hemispherical tank. Got it? You have some thickness for this, just like this. Now this tank is 1 centimeter thick. So this is the thickness. 1 centimeter. If inner radius is 1 meter, now inner radius, this much, is 1 meter. Inner radius is 1 meter. Then find the volume of the iron used to make the tank. Now you need to find the volume of this. Now volume of this is 2 by 3 pi r cube. Now for this r, what you'll do, you'll directly go for inner and outer. Now what you'll do, this is a thickness. By this thickness you'll find the outer radius. Outer radius is 1. 1 from here to here, this is inner radius. So this is 1 plus this 1 centimeter. 1 centimeter is 0.01 meter. 0.01 meter. So outer radius is 101 meter is the outer radius. Got it? Outer radius. Just like this. Then you apply 2 by 3 pi r cube. Now for r, what you just do, let me just show you, make a note for this question. Let me just show you this question. This is as similar as in case of cylinder, where you have outer and inner radius. Then for square you will do outer square minus inner square. Similarly for in here, what you do for cube, you'll do outer cube minus inner cube. Like this, I'll show you. Question number 6. Anything else is given? Find the volume of the tank. Yes, you need to find the volume. See, here inner radius, let's say R1 is equal to how much? 1 meter. Thickness is 1 centimeter, and that is equal to 1 by 100 meter. That is 0.01, 1.01, sorry. Sorry, 0.01. 0.01 meter. This is the thickness, which implies that when outer radius R2, outer radius is equal to how much? Outer radius is 1 plus 0.01, and that is 1.01 meter. That's your outer radius. Got it? Therefore, volume of hemisphere. Volume of hemisphere is 2 by 3. First of all, you can write volume of tank. Volume of tank. That is equal to volume of hemisphere. Volume of hemisphere. And that is 2 by 3 by R cube. Now you need to consider both inner and outer radius. Whenever you have outer and inner radius, you write capital R. Now that capital R, if it's square, then it is equal to R2 square minus R1 square. If it is cube, it is R2 cube minus R1 cube, where R1 and R2 and R1 are outer and inner radius respectively. Now in here you'll do 2 by 3 times 2 by 3 by, now you have R2 cube minus R1 cube, just like this. Then you have 2 by 3 times 22 by 7, then R2 is 1.01 cube minus R1 is 1 cube, like this. And then you can solve this. 1.01 times 1.01 times 1.01 minus 1 times 44 divided by 21. So you have 0.06348 0.06348, yes. Write approximately, which is of the order 0.06348 cubic meters, and that's your answer. Make a note. Then you have question number 7. Find the volume of a sphere whose surface area is 154 square centimeter. Now surface area is given. First of all, you can apply the formula for surface area, that is 4 pi r square. Equate that to 154, you'll get the radius, then find the volume, 4 by 3 pi r cube. A dome of a building is in the form of a hemisphere. From inside it was whitewashed at the cost of rupees 498.96. If the cost of whitewashing is rupees 2 per square meter, find the inside surface area of the dome and the volume of the air inside the dome. So you have a dome is in the form of a hemisphere. It's like this. Let me just show you. This is a dome. Dome is in the shape of hemisphere. From inside it was whitewashed at the cost of rupees 498.96. Rupees 498.96. If the cost of whitewashing is rupees 2 per square meter, at the rate of rupees 2 per square meter, find the inside cut surface area of the dome. Now simply you can do one thing. Inner curved surface area. Go with inner curved surface area. Inner curved surface area here of this hemisphere is equal to 2 pi r square. This is the inner curved surface area, twice pi r square. Okay, you don't know the radius. Now do one thing. 2 pi r square, yes. Just like this, keep it like this. Then you have, since cost of whitewashing, is it whitewashing? Yes. Cost of whitewashing. Cost of whitewashing inner curved surface area per square meter is how much? Is rupees 2. Therefore, cost for this much square meter, 2 pi square meters. Cost for 2 pi r square meter is nothing but 2 times 2 pi r square, that is 4 pi r square rupees, 4 pi r square. Now this is the total cost of the whitewashing inside the dome. Now according to condition, that is 498 point this. According to condition, 4 pi r square is equal to 498.96. Got it? In that case, you'll get r square as 498.96 divided by 4 pi. Got it? R square is 498.96. Then let's drop this. This is the 7th question. Got it? Now r square is this. Now let's come here, which implies that r square is equal to 498.96 times 7 divided by 4 times 22. Then let me solve this. 498.96 times 7 divided by 88, so we'll get 39.69. Therefore r is equal to 6.3. So you got the r as 6.3, and we need to find inner curved surface. Now you got the r, find the curved surface area, inner curved surface area. Then CS inner is equal to 2 pi r square. 2 pi r square, that will give you 2 times 22 by 7 times 6.3 square, and that will give you 6.3 times 6.3 times 44 divided by 7, 249.48. It's meter per square meter, and that's your answer. That's your answer. Now the second part is to find the volume of the air inside. That means find the volume of this dome, 2 by 3 pi r cube. You have radius, so put the radius in 2 by 3 pi r cube, you will get the volume of air contained in this dome. Make a note. Then we have question number 9. 27 solid iron spheres, each of radius r and surface area s, are melted to form a sphere with surface area s dash. Find the r dash of the new sphere. 9th question. It says 27 solid iron spheres, each of radius r and surface area s, are melted to form a big sphere with surface area s dash. Find the radius r dash of the new sphere. So it goes like this. Since volume of volume of new sphere. Volume of, is it a new sphere? Volume of new sphere. Because you melted 27 spheres to form a big sphere. That means volume of these 27, combined volume of these 27 spheres is equal to the new volume of new sphere. So volume of new sphere is equal to 27 times volume of sphere. Volume of older sphere. Old sphere. Got it? Which implies that the volume of new sphere is 4 by 3 pi r dash cube is equal to 27 times 4 by 3 pi r cube. Got it? 4 by 3 gets cancelled, pi and pi gets cancelled. Now you need to find r dash. So r dash is equal to cube root of 27 r cube. That is cube root of 27 r cube. Cube and cube root gets cancelled, and cube root of 27 is 3r. That's your answer. So new radius is 3 times the older radius. Then you need to find the ratio of s and s dash. Part second. This was part first. This was supposed to be the first. It was not part second. Ratio of s and s dash. So s is to s dash is equal to s by s dash is equal to s is 4 pi r square divided by 4 pi r dash square. 4 pi gets cancelled, so it's r square by r dash square. That's it. Now what is, now see, r dash is 3 times r. R dash is r dash square. Now we write r square divided by, from r dash is 3 times r. So I'll write 3 times r square. So that will give you r square divided by 3 is 9r square. Now r square gets cancelled, so that will give you 1:9, and that's your answer. Make a note. Now question number last is: a capsule of medicine is in the shape of a sphere of diameter 3.5 millimeter. How much medicine in cubic millimeters is needed to fill the capsule? So all you need to do is just find the volume of capsule in the last case. That's the easy one. 4 by 3 pi r cube. By diameter you'll get the radius and you'll get the answer in cubic millimeters, because diameter is also in millimeter, so you'll get it easily. You just need to find the volume in the last question. That's your answer. 4 by 3 pi r cube. R you can find from radius, 3 by 3.5 divided by 2, and that's it. Hope you understand all this, and by this, alhamdulillah, we are done with the surface area and volumes. See you next time. May Allah subhanahu wa ta'ala bless you all. Assalamu alaikum wa rahmatullahi wa barakatuh.